Discuss the continuity of the function f defined by f of x is equal to x plus 2 if x is less than or equal to 1 and x minus 2 if x is greater than 1. So let me show the graph. We'll begin with the graph. So we have the graph for the same condition. You can look at this. X plus 2 if x is less than or equal to 1, else x minus 2. So this is your graph. Now what is happening? So after 1, this is your line and you can see it is continuous. And when it comes to at 1, it disappears. Right? It jumps over here. And then after that again it's continuous. So since we have to discuss the behavior, we have to talk about 3 different cases. Again, remember we are discussing the cases. So cases that we have to discuss is less than 1, at 1 and greater than 1. Right? Now, let's start with let case. Let me do case by case. Let's consider C less than 1 and C belonging to R. Now, we can look at the limit f of x as x tends towards C. Remember, all these values are less than 1. So how does it behave? This is where you guys have to answer the question. Yes, it behaves like x plus 2. So when I do apply the limit, I'll get C plus 2. Then what is f of C in this case? This 2 is C plus 2. So clearly the x or the function is continuous for x less than 1. Now case, let's see, represent all the values wherein we have it to be more than 1 and this belongs to R. Then we have limit f of x as x tends towards C. Again, what is the behavior? You guys have to answer this. It is x minus 2. And on direct substitution, we will get C minus 2. So this is on direct substitution. And this too is on direct substitution. Now, f of C in this case will be what? C minus 2. And one last case. Let C be equal to 0. So we have limit. We can approach a point in 2 different ways. One is from left hand side. If I approach from left hand side, what is the behavior? The behavior is x less than 1, that is x plus 2. Okay, if I'm approaching not 0, 1. If I'm approaching 1 from the left hand side, it is x plus 2. It behaves this way. Then in this case, we have x approaching 1 itself from the left hand. Okay, and we have on direct substitution 3. Now we will approach it from the other end. So we have what is the behavior from the other end? From the right end of the 1, this particular line is given by x minus 2. Right? All I have to do is substitute it over here and we have this to be equal to minus 1. And finally, f of 1. So that would be at 1. What is happening? At 1, as you can see, there's a dot over there which is of this expression x plus 2 for x less than or equal to 1. So this is 1 plus 2, or let me write x plus 2, this is the behavior, 1 plus 2, that is equal to 3. Right? this is for x is equal to 1. Now, what can you tell? Clearly, we can tell that these things are not equal. And so we can conclude the following. Conclusion: as limit is, or we can tell from 1 and 2, again I'm trying to cut short the answer. So from 1 and 2, function is continuous for x less than 1. Similarly, we can talk about first and second. From first and first, second and first, f of x is continuous for x greater than 1. And finally, as limit x tending to c or 1, f of x is not equal to f of 1. Right? Clearly, sorry, this is plus. It's not equal to f of 1, right? When we approach from the right hand side, it's not the same as f of 1. So from this, f of x is discontinuous. Again, they're asking us to talk about the overall behavior, so we need to summarize it at x is equal to 1. So that would be your answer.